So match problem 5 was a bit of a trick. Not really a trick, but again, just a reminder of the idea that we need to make sure the conditions are verified to apply the approach from this section. There's going to be a little bit of a trick to this problem as well, and we'll spend a little bit of time discussing that once we hit it. But everything starts off exactly the same. We first verify that the conditions are met to apply L'Hopital's rule. So we'll take the limit as x approaches 0 of e to the 2x minus 1 minus 2x, which is going to give us e to the 0 minus 1 minus 0. E to the 0 is 1, so 1 minus 1 is going to give us 0. Then we'll take the limit as x approaches 0 of x squared. In this case, that's headed to 0, so the conditions are met. So we'll differentiate the function in the numerator, the function in the denominator. So we'll take the derivative of e to the 2x minus 1 minus 2x to get 2 e to the 2x minus 2, and we'll take the derivative of x squared to get 2x. So now our limit problem becomes the limit as x approaches 0 of 2e to the 2x minus 2 over 2x. So we've applied L'Hopital's rule, and now we can, again, just try direct substitution since that's our best first method for evaluating a limit problem. So direct substitution will give us 2 times e to the 0 minus 2 over 2 times 0. So e to the 0 is going to be 1, so we get 2 minus 2, which gives us 0 over 0. So in this case, we don't have a final answer for our limit, but we do know that our function, the numerator and denominator, meet the conditions to apply L'Hopital's rule again. So in this case, we have 0 over 0, and we got that just by direct substitution in the numerator, direct substitution in the denominator. Even though we worked it out a little bit differently than we did up here, we're coming to that same conclusion. We've got 0 over 0, so we can apply L'Hopital's rule again. And this time we'll take the derivative of 2e to the 2x minus 2, which will give us 4e to the 2x, and the derivative of 2x, which will give us 2. So we're applying exactly the same approach that we did in the first step. All this changes the way we sort of wrote out this verification that we meet the requirements for L'Hopital's rule, and now we're taking the derivative of these two functions. So really what we're doing is taking the second derivative of the original two functions that we started off with. And now our limit problem becomes the limit as x approaches 0 of 4 over e to the 2x, or 4 times e to the 2x, over 2, which will give us 4 e to the 0 over 2. 4 over 2 is just going to reduce to the 2. E to the 0 is 1. So we get 2 as that final answer. So again, the same idea here as the previous problems, verifying, differentiating, and then evaluating that limit. But in this case, we were able to apply L'Hopital's rule a second time. Apply L'Hopital's rule a second time to get to that final limit.